All right, so we're looking at square root functions in their graphs. So I want to consider these two things, okay? Now, you might not know what that looks like, okay? What am I talking about? This one right here, the square root of x. You may not know what that looks like, okay? You may not know what that looks like. But if I asked you to compare this to this, you better know how this looks compared to that based on last unit, right? This is whatever that was, except this has been shifted to the left 3 and down 2. Agreed? So those rules that we talked about in the last unit can apply to these. Fair enough? All right, so without the use of your calculator, let's graph this, and then let's graph this. What's a way that we can figure out what this looks like without a calculator? Give me a way. Look it up on Google. Yeah, I mean that's a good idea. What if we don't have Google? Decimals, sure. I don't want a graphic, guys. Say again? Yeah, just create a t-chart. Points, get some points, right? So I'm going to do x, and I'm going to do radical x. Right? That's going to give me an x and a y. Give me a value you want to plug in. All right, so I heard 0. Yes? Oh. What's the square root of 0? 0, right? Okay. Give me another number you want to plug in. 4. What's the square root of 4? 2. Give me another number you want to plug in. 11? Yeah, that might be a little tough to graph, the square root of 11. You know what I'm saying? Like the 11's fine, I could do that, but the square root of 11 is a decimal. So I could, but it would be a little weird, right? What might be a better choice? 9, yeah, 9. Oops. You guys missed an obvious one. 1, yeah. How come nobody chose like -5 or -4? Why didn't anybody choose any negative numbers? Because you can't take what? The square root of a negative, right? The square root of a negative is not equal to a real number. Right? The square root of a negative is not equal to a real number. Why? Anybody know why? Anybody know why? It's actually a really easy reason, right? Guys, why did you say the square root of 4 is 2? 2 times 2 equals 4. Why did you say the square root of 9 equals 3? 3 times 3 equals 9. So why can't I get the square root of radical 4? Because to get the square root of a negative number, you would have to have two numbers that are different, right? To get a -1 or a -4, you would have to have a positive and a negative number, so they can't be the same, right? So that's why. Does that make sense? Right? Okay, so I got some points to graph. 0, 0, 4, 2, 9, 3, 1, 1. And that's that, right? That's the graph that we just created. All right, and then it said that we can graph this one. All right, so I'm going to take this graph, I'm going to shift it left 3, and I'm going to shift it down 2, right? So the easy way to do that is just to take each of the points, just do them all individually, right? Left 3, down 2. And there's this one. Same graph, right? Just shifted. Use your calculator to generate a table of values and graph this. Well, we don't need a table of values. We just did it, right? But here is something that I want you guys to see. When I do this, when I put that radical x in, there's the graph, right? So we see it. And then here's the table. And then just notice something. What the calculator gives you is this, right? What it's saying is error, okay? It's hashtag E, which stands for hashtag error, all right? Is that cool? Hashtag error. State the domain in the range then. And it says to do so in set builder notation, okay? A reminder of what that looks like. Set builder notation. We haven't done this in a while. You do these squiggly things. You do a variable. You do a vertical line. You do some sort of inequality. And then you close up your bracket, right? That's your set builder notation. So it's basically what? It's basically an inequality with all this other jazz around it, okay? So if I look at my blue graph, you guys said that I can't plug in any what? Any negative numbers, right? So give me an inequality that represents what I'm allowed to plug in. Give me an inequality that represents what I was allowed to plug in for the blue one. You guys said I could plug in 0. You guys said I could plug in 1, 4, 9. So an inequality would be what? X values had to be greater than or equal to 0, right? Greater than or equal to 0, because I was allowed to plug it in, right? So for this one, the domain, that. And looking at that blue graph, again, what are the y values when I do that, guys? What were all the y values? Weren't all the y values ones that were also greater than or equal to 0, right? There were no values that were going to be below that, correct? Yeah, so now I'm going to say the range is y is an element of y greater than or equal to 0. Now, the next piece. Look at the green one. Was I allowed to plug in values that were less than 0 here? Yeah, I was allowed to plug in -1, -2, and -3. Agreed? So would you agree that the domain would be values of x that are greater than or equal to -3? And then what about the range? What's the lowest point on this green graph? -2. So everything greater than or equal to y being -2? All right. And guys, we did this already. What transformations, right? We already talked about the transformations. That was up top. All right, so let's see if we can figure out which of these created this, right? So guys, I'm really thinking again about last unit, right? I'm really thinking about last unit. So if I started with this curve, right? If I started with this, what did I do to this to get this? Right? What did I do to this to get this? Anybody want to venture a guess as to something that we did? So there's a shift and a reflection, okay? No doubt about it. All right, let's be specific now. What's the reflection? All right, so we have a reflection over the x-axis, and we have a shift, again, specific, left, 4. Okay, so that's what was done, right? That was done. Now the question is, which letters create these things, right? So if I shift left 4, what am I looking for? An A, B, C, or D? Am I looking to be inside or outside of the parentheses? Or in this case, the radical? Inside, yeah. And if I want to go left 4, what am I looking for? Plus 4, right? This would be a shift where? To the right. This would be a shift to the right. So it's not going to be this or this. And if I look at this one, guys, has this one been shifted left or right at all? No. So the only one that makes any sense at all would be that first choice, because this shifts left 4, and this is a reflection over the x-axis. Cool? Which of the values does not lie in the domain? Which of these values do not lie in the domain? In other words, can I plug 6 into this? Ariel's shaking her head yes. Why? Because it's fine. It's what? Okay, so all right. So if your explanation, it says explain why I can do that. Why am I allowed to plug in 6? Okay, good. So you're thinking of this graphically. Okay. What if we don't think about it graphically? What if we don't think about it graphically? 6 minus 5 is 1, and the square root of 1 gives me a number that is positive, right? I just got to make sure when I plug something in, the thing underneath the radical isn't what? Negative, right? So I can do this because I get this. Right? And so what do we say? I'm allowed to get positive numbers. I'm allowed to get 0. I'm not allowed to get a negative value, right? So this, right? This right here is no good. That's no good. We don't want that. Okay. Now, this brings us to sort of I think one of the most important parts of the lesson. Maybe the most important part of the lesson. Here I want you to just tell me the domain, right? Determine the domain in set builder and interval notation. I don't want to graph them though. I don't want to graph them. So if I look at this first one, can I plug in 0? Yeah? Can I plug in 1? Can I plug in 3? Can I plug in 10? Can I plug in -1? Yeah, because what's -1 plus 2? Can I plug in -2? Can I plug in -3? No, right? Because -3 plus 2 is a negative value, no good, right? So here's what we know. Whatever's underneath, we want to be positive or equal to what? 0. Isn't it true then that this needs to be positive or equal to 0? Can you guys solve that for x? All you gotta do is what? Subtract 2. This creates my domain. That creates my domain. Those are all the values I'm allowed to plug in. Now it said to write them in interval and set builder. We'll do that in a minute. Okay? 3x minus 2. Whatever's underneath the radical has to be greater than or equal to 0. Can I solve that? Just pretend it's an equal sign, guys. What can I do? Add 2. And divide by 3. That's my domain. Whatever's underneath the radical has to be greater than or equal to 0. This one's going to be tricky. What do I need to do first here? Subtract the 8, right? Then I'm going to what? Divide by -2, and that's the tricky part, guys. Why is that tricky? Because what am I solving? Solving an inequality. And what has to happen when I divide by a negative? The inequality has to flip, right? So I have to take that inequality and write it the other way, right? Flip the inequality, right? And again, the only time we do that is when we divide or multiply by a negative. Okay? And again, that creates my domain. All right? I don't feel like putting these in set builder. Forget it. We'll skip that. Is that okay, guys? All right, last bit of the day. It says, consider this function. So guys, I've just sort of messed you up completely because what do I have now? I have this, right? And what's underneath the radical? A quadratic. Okay, well, we'll see how that's going to play in a minute. Use your calculator to sketch this on here. All right, so I have radical x squared plus 4x minus 12. Boom. Weird, right? I mean, if we got to sketch it, let's see, it's -1, 2, 3, 4, 5. That's -6. That's 2. And it looks like it just sort of like flies out in those directions, right? It doesn't look like there's much shape similar to what we saw before, right? Totally different. One, 2, 3, 4. -6, 2. Looks like this. Well, let's talk about why it looks like this. What did we say about the thing under the radical? We did it all on the previous page. The thing under the radical has to what? Be greater than or equal to 0, right? So the domain of radical x is always x is greater than or equal to 0, right? So if I want the domain of this, give me that, right? It's where x squared plus 4x minus 12 is greater than or equal to 0. All right, so I'm going to show you guys a really easy, simple way to think about this. Ready? You guys agree that this is a parabola? Yes or no? Yeah? Happy parabola or sad parabola? Happy parabola. Why is it happy? Because the x squared is positive. Do I know what the roots are of this parabola? What I mean by that is this, guys, right? We know if we grab, here's what we know, no doubt about it. That's the what? Y-intercept. It's a happy parabola, right? So I know this much right now. I know that it does this, right? It's going to go through this point, and I know it's happy. Agreed? So I know it has to look something like this, which means it has to have how many roots? 2 roots. How do I get the roots? I take x squared plus 4x minus 12, and I set it equal to 0, and I factor, and I get my roots. So the roots are going to be found by doing that. How do I factor that? Well, I need to do one of these. Give me 2 numbers that multiply to be negative 12 and add to be 4. I hear a 6 and a 2. Can I get signs on those? Positive 6 and negative 2. And what am I supposed to do with those now? Set those both equal to 0 and solve to get the roots, right? Okay, got my roots? Here's negative 6 and here's 2, right? Everybody agree with that? Hey guys, where is this graph greater than 0 or equal to 0? Is that part greater than or equal to 0? Is that part greater than or equal to 0? What did our graph sort of look like? Right? And so what's the domain of this? Am I allowed to plug 0 in? Okay, that's where this part gets confusing. Ready? Do you see where the yellow part's highlighted? Where does the yellow part start being highlighted? At negative 6. Is it highlighted at negative 7? Why are we saying no? If I go to negative 7, is there a point on my graph at negative 7? At x equals negative 7. Yeah, because this graph moves which direction? To the left and up, right? Is there a value at negative 8? Is there value at negative 9? Is there value at negative 10? Is there value at negative 3? No, because negative 3 brings me where? Down here, right? Is that part of the highlighted solution? No. Is there a value at 0? Is that part of the highlighted area? No. Is there a value at 1? Is that part of the highlighted area? Is there a value at 2? Is that part of the highlighted area? Yes. At 3. Shay, ready? Look. Because this point right here, right? Well, of course. Again, so guys, here's the thing. The answer to this is everywhere that is less than or equal to -6. And the answer to this is everything that is greater than or equal to 2. Like that. And that would be your domain. Guys, what if I did, this is, I know this isn't part of your packet. What if I asked you guys for the domain of this? -x² plus 9. Okay. What do I know about the domain? I know the domain is that -x² plus 9 has to be greater than or equal to 0, right? Do you guys agree that this is going to give me a parabola? Talk to me about that parabola. It's sad. Give me something else you know about that parabola. It has a y-intercept of 9. So I know right now that it's going to look like that. Yes? Okay, what do I need to find? The 2 roots. Okay, so what are my 2 roots? Well, it's where this equals 0. This one's a little bit more difficult to factor. Watch what I'm going to do. I'm going to take a -1 out as a GCF. This is a little weird, okay? If I take a -1 out as a GCF, you see how it's -1 and now it's x² minus 9 because I took a -1 out of both of those? Can I factor x² minus 9? It's a difference of perfect squares, isn't it? It's an x plus 3 and an x minus 3. Which means I'm going to have roots of positive and -3, aren't I? So that means I have a root here and I have a root here. Okay. Now, what do I want to know? I want to know where the parabola is greater than or equal to 0. Where is the parabola greater than or equal to 0? All of that. Because where? It's above, right? I want to be greater than 0, which means above, right? So, ready? What's the domain? It's everything that's highlighted. Is 0 part of the domain then? Yes, because 0 brings me where? Up here on the yellow. Is -1 part of the domain then? Yes. Is -5? Because where's -5? It's out here, which brings me down here, doesn't it? So what would be the domain? It would be everything between -3 and +3. So the domain for this would be everything between -3 and +3. Okay? And those are your 2 scenarios, guys. You're either going to have a happy or a sad parabola, right? Exactly. It says 3. This one right here? Yeah, oh, no, it says -3 is less than x is less than or equal to 3, right? So in other words, if I pick a value of x, -3 has to be less than it, which puts me to the right side of it, doesn't it? And then x has to be less than or equal to 3, which puts me to the left side of this one, which puts me in the middle. You got it?